Hello and welcome to another TechBite video from CMG. My name is Farad Sari, and today I'm going to overview PyControl, the latest application from CMG. So PyControl is going to be introduced as part of 2022 general release, and it streamlines two-way couplings between the Python script and the simulator. So if you're familiar, Gem, IMEX, and stars were able to communicate to third-party applications or script using outboard, but that needed a lot of file exchanging and signaling between two platforms. Now, PyControl converts all those processes to an internal routine and allows user to really focus on the script and how to control the simulator. It comes with GUI that gives you an easy access to the current simulation results. And once you've done all your analysis of the data and analyze the current simulation outputs, the code has to decide on the right reaction. Those reactions are converted in the form of Reservoir Simulator keywords, and they're passed back to the simulator in real time. So appending those keywords in the recurrent section, we can alter the simulation progress in real time. In terms of benefits, Trigger is a limited version of PyControl, if you like. Using Trigger, we can monitor a certain condition, and if that condition is met, we can append some keywords. But PyControl gives you a wholly different level of control on the simulator, because now we have access to much more information from the simulator in real time, and we can return any valid keyword in the recurrent section of the simulator back to the run in real time. Using Python, there are a lot of open source free packages for the data processing in sources like GitHub that can be engaged and embedded in your script, and we can set the right level of handshaking frequency, so script and the simulator can update each other as frequently as needed. Or even if needed, user can engage multiple sessions of PyControl with one single data set, and allowing the run to be manipulated by more than one script. In terms of workflows, let's have a look at the list of the current information results. So here on the left-hand side, I've listed those sources. So as you expected, well groups, layers, sectors, and current and elapsed simulation times. Hopefully in the future releases, we also get access to the grid data. Things like current saturations, current temperatures, and pressure. But for now, we have access to all the other sources in the list. For each source, there's a list of the parameters that is currently available again. In terms of Python scripting, this is really where the user has to focus. So once you've read all the current simulation outputs, the code has to analyze the data. Those analysis might be a simple if and else condition, or you might engage really more complicated plugins to account for things like hydrate formation that might not be fully mechanistic model currently available in CMG. So after those processing, the code has to return some simulator keywords. Those keywords, depending on which simulator you use, there's a list of accepted keywords in the recurrent section. Obviously, any keywords that's in the recurrent section can be returned. On top of that, GEM, IMEX, and stars, they also accept keywords from other sections, things like permeability or endpoint scaling can be updated in real time. But in many cases, user just want to update their well and group controls, or you want to change the geometry of the well, adding a skin, or that sort of more commonly used remedies. In order to return the information back to the simulator and the users, we have two syntaxes to use. So any keywords that has to go back to the simulator comes under this syntax, obdata.info to sim, and then you return a string containing the actual keywords that you would like to be appended in the simulation deck. And you can also pass a message to the user and update and give a note to the user that what's going to happen now with these changes. Let's have a look at the demo. The first one, I'm going to use PyControl to control injection and production in a gem data set. So it's a very simple data set. We have two wells. The injector is open and constantly injecting. Producer is closed currently, and we want to use the PyControl in order to open and shut these keywords and maintain the average sector pressure, average field pressure between 15,000 and 22,000. So let's go into the PyControl and have a look. Okay, here I have Launcher 2022 general release, and I have different applications that came with this release. You'll notice the new icon with PyControl. We're going to use this in our demo today. So I have, this is my base data set. I grabbed one from the GEMS template folders and just made a copy of the same data set. These two data sets are exactly the same. The first one is simulates the scenario that I explained, a constant injection, and we're going to control second data set with PyController. So I can drag and drop the data set into PyControl. So with that, this window pops up. If you have already a script and you want to engage with this data set, we can bring that. Otherwise, we can create a new script. So let's create a new script in this case. We can put a name and let's call it switch. And that's going to be automatically, the file is going to be created and with a Py extension, meaning that's it's a Python file. So if I maximize the application, there are different sections in the PyControl. It probably feels a bit similar like cedit if you use that. On the top, we have different tabs with access to certain functionalities, things like copy, paste, commenting a line. So this line is a comment. And if you want to add any new comments, you can start typing, hello, this is a test. And obviously this has to be a comment. So you can use this comment and take it out of the actually active lines. You can place bookmarks and to go back and forth if needed. Obviously, you can zoom in. You can also hold the control key and mouse wheel in order to zoom in and out. This gives you a quick access to the folder that these files are stored. And Snip Manager, we're going to come back, gives you flexibility to load more snippets if required. There's a basic and advanced mode for any user. Obviously, we're going to stick with basics. And if you're really familiar with the scripting in Python, you might switch to advanced if needed. So any new script automatically is going to come with these lines. So what this lines does is telling the PyControl that we don't want to couple at the really day zero with initialized values. and the coupling will only happen once the first time step has been completed. So that's usually what we want to do. We don't want to take actions based on the initial values of the simulation. On the bottom, we have the variable tabs. So if you use this button, you can say add a new variable. You can put any name that you want. Say, for example, you're going to define a new variable, call it production rate. So prod rate. You can choose the name as required. The source, it's going to, in this case, you can choose the right source. In this case, it's going to be from wells. So if you choose wells, for wells, we have the option to choose the well name. So obviously, in this case, I'm going to choose the producer. But if you have like 200 wells and you want to put all of them in an array, you can choose all producer, or you have an option to choose all the wells. So all the injectors and producer will be stored in this variable in the form of an array. In this case, I'm going to use the simple producer. And for a producer, I have a list of potential variables. So the one that I am interested in is going to be, say, STG, so total gas production. I can make a copy of this variable and write a new variable. Say, for example, in this case, I'm going to use inj rate. So inj rate, and obviously it's going to be again from the well. And in this case, instead of producer, I'm going to untick and choose producer, and still I want to look at STG. Let's define a new variable. So for example, if I had to look for something like average reservoir pressure, they call it average pressure. The type of this variable is going to be a sector. And for a sector, if you have multiple sectors, it's going to be populated in this list. And you can also choose the right parameter here. So in this case, we're going to look at this variable, average based on the pore volume. So anything that you noticed as we are changing in the variable section is going to be reflected on the top. So these two are synchronized automatically. You can even define by typing. So I can define a new variable, something like water rate. So let's call it water rate. And if you use the same syntax from sim underscore data dot wells, if you start, once you put dot, you can choose the right source for this variable. So let's say something like wells. I'm interested. Once you selected wells, if you open the brackets, you have the options that pretty much happens or become available in the variable section, or also automatically pops up on your screen. I'm gonna say water rate producer, and if you go to the end and press dots, you can choose the right profile. In this case, I'm interested in, say, something like STW. So that's another way of defining variables. You've noticed that the file that I loaded had a name tag of py.dat. So the naming is completely arbitrary. You can choose any name that you want, but usually I prefer to have this a tag of Py, just to as a reminder that this is a for Python control dataset, and that's the dataset that we're currently working on is noted here, and those variables that we can choose are automatically read based on this dataset. So then the well names, sectors, everything will, once you load it, once the PyControl is initialized when we first started, gathers all the information and knows what data are going to be available. So based on that, this variable pan works. On the snippet section, if you're not familiar with the Python syntax, these snippets might be useful. So if I don't know how to write an if and else condition, can double click an if and else line, an example appears, and you can refill, exchange that with the your data with the right syntax. So in this case, let's delete that. I'm going to write an example from scratch. So let's delete that. And you can also, there are some examples here. So things like controlling data, the well based on layers, or average reservoir pressure. There are some examples that might be useful. In this case, I'm going to really start by everything from scratch. So I defined my three variables. So going back to the scenario that we were simulating, I need an if and else condition. So let's again bring back the if and else condition. So the condition, the first condition, so if you remember, the injector was open, and the first change is going to be the switching the injection to a production. So let's make that scenario. I want to write an if condition. So my if condition is going to be if average reservoir pressure is larger than 22,000. And the syntax, we want to add another condition, and we want to make sure actually that the injector is open. So the injection rate, if the injection rate is non-zero, is larger than 0, then we want to return some conditions to the, we want to return a keyword to the data set. Those keywords, if you open this plus sign, there's a note on how to return keywords. So this one, OB data, as I mentioned in the slides, this is the syntax for returning keywords. So I can copy that into my script, and the keyword that I want to return is going to be shut-in injector. So I can delete this, and I want to return a string, and the string is going to be shut in. The well name is going to be injector. Injector, and close the quotation. And we want to also open the producer. So I'm going to copy this, the same. I want to, apart from this keyword, I want to return another keyword, and that's going to be open. And the well name is going to be producer. And so these keywords go back to the simulator. I want to return a message to the user saying that what's going on. So I can copy this syntax in the log file. So let's copy this, and I want to return a message called something like switch to production. So switch to production. Okay, so that's one. That's how we take action for the switching. I can write another if condition saying that if the reservoir pressure falls below 15,000, then take the other way around. So open the injector and close the producer. In the interest of time, I have already a syntax completed, so I'm going to close this session and load that script. So let's close that. And again, I'm going to reopen the script that I have ready is called alternate.py. It's already saved. So drag and drop into the dataset to PyControl. I'm going to maximize again so you can see the scripts. And this is the script. I need to attach the dataset to the script. So you're going to say browse for the file. So that's going to be Py. So you can see the scanning the dataset, the keywords and the recurrent section all scanned. And these are the variables that we're going to read. And here's the script, the same, pretty much the same script. If the pressure goes above, then switch to production. If the pressure falls below 15,000, then stop production and start injection. So now this is my script is complete. So I need to run. I want to just run. So say run. This window pops up. Obviously, you can choose the number of CPUs that you want to choose. The version of simulator has to be 2022 and later. You can't run the older versions of GEM with PyControl. Here you have a chance to set the coupling date. So if you want to start the coupling from day 0, that's the default. But if you want this controller to only take control after the first year or whatever, you can choose the right date. Completely up to the user to decide. Here on the additional switches, you can pass any simulator switch to the gem in this case. The one that I recommend is to use the switch of record. So that's gonna record all the communications between our script and the simulator. So let's press run. And with that, 2 windows pops up. So the first one here on top of each other. So this is the usual gem log file. If you're familiar, we can see all the time stepping that takes over. And here in the other window, there are the messages that we are seeing from the controller. So we can see that already switched to producer, and we switched back to the injection now. And this takes a few seconds while we're running the simulator. You can see all the updates in this window. So I'm gonna stop here. Here I loaded 2 SR3 files from the base datasets and from the one that was controlled by Python. And I already plotted the average reservoir pressure. If you have a look, the initial pressure started at 17,000. I have in red the Python controlled behavior, and in blue the other case, which is the base case. As you see, just keeps increasing the pressure. The simulations results were exactly the same until this point that the pressure went about 22,000. So at that point, we switched to production, and you can see the Python pressure controlled case starts to decrease. We went below 15,000, and at some point we went below 15,000. You notice that it's not exactly 15,000. The reason being is that we decided by default the controller and simulator only talk every month to each other. So by the time we completed the next coupling, by the time we reached the next handshaking time, simulator might already have dropped the pressure below the accepted level. But as soon as handshaking happens, we switch back again to the injection, and you can see the pressure started to increase, and then again we went about 22,000, and again we started to production. So that was all I wanted to show in terms of PyControl. I hope this was useful. Please consider subscribing to our YouTube channel and turning on the notifications so you get notifications for any new tech bites or other videos that we upload in our channel. Have a great day. Thank you very much.